Hello, welcome back. This is Calculus by Dr. Oz. Today we're going to find derivatives involving hyperbolic functions. And in part A and B we have composite functions, and in each one we have tan hyperbolic function involved. So at this moment it's better to refer back to this table here that involves derivatives and integrals of hyperbolic functions, but we're more interested in the left-hand side of this table for the time being because we have the derivatives of all six hyperbolic functions, and I'm gonna refer back to that in the video. So why don't we get started?
All right, let's look at part A. We have tan hyperbolic 4x squared plus 3x in part A. Let's go back to the table where we have the derivatives and as well integrals of hyperbolic functions. Now what we're interested here is this specific formula taking care of the derivative of tangent hyperbolic u. And here, take this as like u is a function of x. So you take the derivative of that, the derivative of the outer function, which is secant hyperbolic squared u, and multiply everything by the derivative of the inner part here, which is u prime, when you take the derivative of that. So it's the application of the chain rule in some sense, because tan hyperbolic x has the derivative only secant hyperbolic squared x. But if there is a function of x for tan hyperbolic, and u is replaced by that function, so you have to sort of like take care of u prime and multiply the whole quantity by that at the end, by the prime of that. Okay, so let's go back to this example here that we have an outer function here, ln, right? We have an outer function. I'm sorry. We are still in part A, right? Here we go. Tan hyperbolic of u. Okay, so this is, let me call this function to be u. So u is equal to 4x squared plus 3x. And I'm going to use the formula here. So f prime is equal to secant hyperbolic squared u times u prime. Let's write that carefully. And u prime here is 8x plus 3. There we go. Secant hyperbolic squared 4x squared plus 3x times, this is a separate function, right? 8x plus 3. So this has nothing to do with the argument of secant hyperbolic squared. So to be safe, just replace the positions of 8x plus 3 and secant hyperbolic squared function. So you won't get confused that secant hyperbolic squared comes with this argument only, but not this. Okay. All right, that takes care of part A. Why don't we do part B in this video as well, so that we don't have two parts. Let's check this out. So you have ln of tan hyperbolic x over 2. You have the outer function ln, inner function tan hyperbolic x over 2, but that also has an inner function here. Okay, so let's do like multiple substitutions here on a separate place here. I'm gonna call u to be x over 2, so that tan hyperbolic x over 2 is tan hyperbolic u. Okay, and tan hyperbolic u, because of the same formula that used in part A, is secant hyperbolic u times u prime. And here u prime is just 1/2. Okay. So this is equal to secant hyperbolic squared x over 2 times 1/2, but I'm going to put the 1/2 right in front. Okay. So this is good because I just took care of the derivative of the inner part here, right? Tangent hyperbolic x over 2 prime. So let's use the chain rule here. F prime of x is the derivative of ln. Okay. If you want, let me just call this v so that you won't get confused. So the derivative of that is ln v has a derivative v prime over v, and you can sort of like grab that formula from the basic integration, basic differentiation rules. This is for the integration rules. I don't think that I have it in this PowerPoint slide, but check back that ln v. Let me just write that here. ln v prime is v prime over v. Okay, check this. Please check this formula. Okay, I just wrote it. Okay, or you can go with the u version of that, right? ln u prime over u. Okay. All right. V prime is just calculated here in blue. Okay, 1/2 secant hyperbolic squared x over 2. I'm going to divide this by tan hyperbolic x over 2. Okay. So the question is like, can you simplify this expression? Okay, can you simplify this expression? Okay, so since I don't need those, let me just get them out of the way. The question is, can we simplify this expression? Well, by using the properties of, or definitions of secant hyperbolic and tan hyperbolic. Well, first of all, secant hyperbolic squared is 1 over cosine hyperbolic squared x over 2. And tan hyperbolic x over 2 is sine hyperbolic x over 2 divided by cosine hyperbolic x over 2. Okay, so by using the definitions of secant hyperbolic and tan hyperbolic, I'm going to flip the bottom over so that this will look like here, cosine hyperbolic x over 2, sine hyperbolic x over 2. Okay. And this is already squared, right? So I'm just be careful here. Okay. And then this cosine hyperbolic square is going to cancel this power here, right? In the bottom in the second fraction over there. There we go. So then this turns out to be 1/2 cosine hyperbolic x over 2 times sine hyperbolic x over 2. And just for the sake of practicing the double angle formulas, check this. Please check those hyperbolic identities table. And as you see that if you have the product of sine hyperbolic x and cosine hyperbolic x together with 2, that's the double angle formula for hyperbolic functions for sine. So this can be rewritten as sine hyperbolic 2x. So I'm going to go ahead and practice this here. I have 2 here, cosine hyperbolic x over 2, sine hyperbolic x over 2. I can go back up here, so prime of x is 1 over sine hyperbolic x, because the double angle for this case is the twice of x over 2, which is just x. Okay. And we can go one more step further, that 1 over sine hyperbolic x is cosecant hyperbolic x. Okay, that's cosecant hyperbolic x. There we go. So I'm going to go back up here. So this is in fact equal to cosecant hyperbolic x. So interestingly, you had a very complicated expression in the beginning that involves ln of tan hyperbolic x over 2, but the derivative is written pretty clean. It's just cosecant hyperbolic x after we simplify that further. And I did those simplifying process just for you to see how I used identities and everything, so that you can make your hands dirty with those identities for future problems involving hyperbolic functions. All right, that was a long video. I'm going to stop it here, but we took care of 2 parts of this question in one shot. So thanks for watching. I'll see you in another video. Bye.